Right now, a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system.
Something strange unfolded on NASA TV. During what was supposed to be a routine update on upcoming telescope campaigns, a senior imaging specialist made an unscripted remark. It lasted only a few seconds but instantly captured the attention of everyone watching. "We've captured the first clear images of 3I Atlas," she said. Then the signal froze. A static frame of the NASA logo appeared, followed by silence. When the broadcast returned, the discussion had shifted to lunar geology. No mention of 3I Atlas. No explanation for the interruption. At first, most viewers dismissed it as a harmless glitch. NASA's public feeds drop frames all the time. But within the astronomical community, the phrasing of that one sentence, "first clear images," set off a chain reaction of questions. Had NASA already obtained high-resolution observations of the mysterious interstellar object? And if so, why hadn't the data appeared in any of the usual archives? To understand why those few words mattered, you have to know what 3I Atlas. Discovered by the Asteroid Terrestrial Impact Last Alert System in 2024, it quickly became the third confirmed visitor from beyond the solar system, after Oumuamua in 2017 and Borisov in 2019. But this one didn't look or act like either of its predecessors. From the earliest images, astronomers noticed something impossible. Its dust tail pointed toward the sun instead of away from it. Under normal physics, solar radiation pressure forces fine dust to stream outward, forming tails that always trail behind the comet. For 3I Atlas, the orientation was reversed. It appeared to be ejecting material directly against the flow of radiation. That single observation broke the rules. It implied either a powerful jet of dust being expelled from the sun-facing side, or a composition so heavy that sunlight simply couldn't move it. Both options were unprecedented. Spectroscopic readings added another layer of mystery. Ordinary comets release gases, water vapor, carbon monoxide, carbon dioxide, as they warm. 3I Atlas released none. Its spectrum was flat, dusty, and silent. No volatile signature. No measurable emission lines. So when a scientist mentioned those results on air, only to be cut off seconds later, it immediately drew scrutiny. Had the observations already been processed behind the scenes? And if so, why weren't they public? Within hours, archived recordings of the broadcast were missing the entire exchange. NASA explained that an audio-video synchronization issue required a re-upload. But independent researchers comparing timestamps noticed that the final file was shorter, by almost 2 minutes. At the same time, several catalog entries for 3I Atlas in NASA's public observation logs briefly went offline. Their exposure times and calibration notes were replaced by placeholders reading, "to be determined." No one called it censorship outright, but the coincidence was difficult to ignore. Scientists who monitor telescope scheduling say such redactions are rare, unless the data is still under internal review. In other words, the images probably exist, but they haven't yet passed NASA's quality control process, or its communications review. Meanwhile, informal channels lit up with speculation. Was the object showing structural detail, a smooth nucleus, layered strata, multiple jets? The idea of seeing an interstellar visitor this clearly was electrifying, and that excitement quickly turned into frustration when the footage disappeared. Even without the missing imagery, the facts are striking. 3I Atlas is hurtling through the solar system at roughly 130,000 miles per hour. Its path brings it alarmingly close to several planets, Mars, Venus, and Jupiter, during a single fly-through. For a natural interstellar object, that sequence of near encounters is extraordinarily unlikely. Its nucleus appears large, perhaps 5 to 6 kilometers wide, and surprisingly bright for something so distant. Polarimetric readings suggest the dust reflects sunlight uniformly, a sign of compact, fine-grained material. Light curve analysis indicates a rotation period of about 16 hours, smooth and consistent. Nothing about it matches the chaotic spin of ordinary comets. Put all of that together, and you see why that accidental on-air comment mattered. If NASA already has first clear images, then someone inside the agency is looking at the answers to those puzzles right now. Images sharp enough to confirm whether the tail truly points sunward, sharp enough to show whether the nucleus is fractured or intact, sharp enough to tell us whether we're watching a natural fragment from another solar system or something even older and stranger. Whatever the explanation, one thing is certain. 3I Atlas has already forced astronomers to question long-standing assumptions about how comets behave near a star. And the briefest comment, one unguarded line on live television, was enough to remind the world that even today, the universe still finds ways to surprise us. The trajectory of 3I Atlas has become one of the most debated mysteries in modern astronomy. On paper, it's simple: an interstellar object traveling through our solar system on a hyperbolic path. But when astronomers mapped that path in detail, what they found didn't look random at all. After entering from far above the ecliptic plane, 3I Atlas descends through the solar system in a curve that threads between major planetary orbits with uncanny precision. In early October 2025, it will pass within 30 million kilometers of Mars. Just weeks later, it crosses near Venus at roughly 0.7 astronomical units. By early 2026, it will swing through Jupiter's gravitational neighborhood at about 0.4 astronomical units from the gas giant. 3 near-planet encounters in one sweep. Statistically, that should almost never happen. Harvard astronomer Avi Loeb and his colleagues have estimated that the odds of such a trajectory occurring by chance are astronomically small. For an object approaching from interstellar space, the probability of aligning this closely with multiple planets on a single inbound arc is effectively near zero. That has raised an uncomfortable question. Why does 3I Atlas seem to follow a path that looks calculated? When NASA plots missions to the outer planets, Voyager, Cassini, New Horizons, engineers carefully design flight paths that use planetary gravity to slingshot spacecraft across vast distances with minimal fuel. Those routes are not arbitrary, they're optimized. And when astronomers overlay 3I Atlas's course against those classic trajectories, the resemblance is uncanny. If an engineer had wanted to move through the solar system efficiently, visiting multiple planets along the way, this is exactly the kind of path they would choose. Each planetary flyby offers a gravitational assist that could adjust velocity or direction without requiring propulsion. That doesn't mean 3I Atlas is anything but natural. But multiple data analysts confirm that several observation entries related to 3I Atlas in the Hubble and GUST archives went offline that same day. Exposure timestamps were replaced with placeholders reading "pending calibration." Normally, calibration takes hours, not days. Independent astronomers tracking the same coordinates reported no similar delay for other targets. Whatever happened to NASA's data, it wasn't affecting anything else. For about a week after the broadcast, almost nothing new was said about 3I Atlas. Then, NASA updated its mission logs to show that new observations were scheduled for late 2025, right before perihelion, the moment when the comet will pass behind the Sun. But the early data, the one referred to during that cutoff broadcast, has still not appeared. Normally, space agencies release raw images even if analysis is incomplete. They're often messy, overexposed, or filled with noise, but they exist for public transparency. This time, the silence continued. In internal memos circulated among astronomers, the object's observation campaign was reclassified under limited distribution. That's not censorship, it's protocol used when data requires additional verification or involves cross-agency review. Still, the result was the same. The most anticipated images of an interstellar object remained unseen. Several hypotheses have emerged for why NASA's data might be delayed. The most mundane is technical. The images could have suffered from cosmic ray interference or focus anomalies, requiring extra calibration before they're useful. Hubble and GUST often deal with these issues, especially when imaging faint, fast-moving targets. The second possibility is more scientific. The images might have revealed unexpected features, surface variations, active jets, or irregular reflections that need confirmation before release. Prematurely publishing ambiguous data risks global misinterpretation, and NASA has learned that lesson before. The third explanation is logistical. 3I Atlas's brightness and position make it difficult to isolate from background noise. If multiple observatories observed simultaneously, combining those results could take months. But there's also a more intriguing possibility, one whispered in academic circles. What if those images don't just confirm anomalies we already knew about? That makes NASA's missing early data all the more critical. Those images might be the only detailed look at 3I Atlas before the Sun hides it from view. Once it passes perihelion, it will accelerate out of the solar system forever, never to return. Was the broadcast cut and the data delay merely coincidence? Probably, but even coincidences can raise important questions about how science communicates discoveries of this magnitude. When data challenges established physics, when something behaves in ways our models can't predict, scientists often hesitate before speaking publicly. It's not secrecy, it's caution. Still, for the public watching that live broadcast, the silence that followed felt like something more. Whatever the truth, 3I Atlas remains one of the most extraordinary natural objects ever observed. Its strange tail, its improbable trajectory, and its missing imagery have turned it from a mere comet into a scientific enigma. And as it speeds toward the sun, every unanswered question feels heavier. Because once it's gone, we may never get another chance to find out what it truly was. Everything now points toward one date, October 29th, 2025. That's when 3I Atlas will reach perihelion, its closest approach to the sun. For astronomers, this is the climax of the story. For the object itself, it's a point of no return. At perihelion, 3I Atlas will be hidden directly behind the sun from Earth's view. When it becomes brightest, we'll be blind. No ground-based observatory, not even Hubble or JUST, will be able to see through the glare. In that window, something extraordinary could happen, and we may never witness it. Some predict the comet will fragment under solar stress. Others think it will flare, releasing long-buried material as it warms. But a growing number of researchers suspect it will remain stable, unchanged, and inexplicably resilient. That resilience, if confirmed, might reveal that its structure is denser and older than anything in the solar system. For the scientific community, the weeks around perihelion are both exciting and frustrating. Telescopes around Earth must shut down observations near the sun to protect their optics. That means a total blackout during the most revealing phase of 3I Atlas's journey. It's like watching a mystery unfold, then being asked to close your eyes during the final act. When the insider said, "We've captured the first clear images," she might have been referring to data that explains all of this. If the images show jets erupting from the sun-facing side, it could confirm a localized vent powerful enough to reverse the tail. If they show a perfectly smooth nucleus, it might indicate a solid, rock-like body rather than an icy one. And if the surface appears stratified, layered, banded, or unusually reflective, we could be looking at material that formed around a completely different kind of star. Chemical composition is the key. Spectroscopic analysis can measure the deuterium to hydrogen ratio, a signature of where and how water formed. If that ratio differs sharply from Earth's oceans, it would prove that 3I Atlas originated in a stellar environment unlike our own. In effect, the comet would be carrying a chemical message from another corner of the galaxy, a sample of a foreign solar system delivered to ours. That's why the missing data matters so much. Each pixel in those unreleased images could hold evidence of how planets formed elsewhere in the Milky Way. Scientists have outlined three major scenarios for 3I Atlas's behavior. 1. The exotic physics scenario. The sunward tail might be caused by electrostatic charging, dust grains responding to magnetic fields rather than sunlight. If confirmed, it would mean our models of comet interaction with solar plasma need rewriting. 2. The composition scenario. The object could be coated in unusually heavy minerals that make radiation pressure ineffective. That would explain the reversed tail without invoking new physics. 3. The structural scenario. 3I Atlas might be a dense fragment of a shattered exoplanet, a relic of another system's asteroid belt. In that case, its uniform reflection would make sense, and its stability at perihelion would reveal a body built to endure extreme heat and time. Each possibility is profound. Each pushes the limits of what we thought interstellar objects could be. Once 3I Atlas passes behind the sun, it will re-emerge in late November. By then, it will be speeding outward at more than 130,000 miles per hour, fading fast. Telescopes will scramble to capture what's left: the dust trail, the debris cloud, or perhaps nothing at all. If it fragments, we'll finally see inside, revealing its true makeup.